All right, we just finished talking about the domain, the range, and the period of trigonometric functions. Now let's actually look at the sign of trigonometric functions. So if I'm in quadrant 1, and the big thing to remember is that we know the sine is the y value and the cosecant is 1 over y. That's why these are related. The cosine, x, and then 1 over x, and then of course y over x and x over y. So these are connected because they're both y's, both x's, both x and y. So if I'm in quadrant 1, which this is quadrant 1, right chair, then I can certainly see that my y value is positive. My x value is positive. A positive and a positive gives me a positive. If I'm over here in quadrant 2, I see my y value is positive, but now my x value is negative. A positive and a negative, a negative. If I'm in quadrant 3, I have my y value now negative, my x value negative, and a negative is a positive. And then finally quadrant 4, my y value is negative, my x is positive, and a negative and a positive would be negative. Okay, so that you're going to see this is important to be able to figure out what quadrant you're in, okay, for one, and then to figure out the sign of the trigonometric function. So this says find the quadrant in which an angle lies when the sine of theta is less than 0. So the sine is y. So that tells me I'm in that one or that one. That's the only place where y is negative, but then and where cosine is negative. Cosine is the x, and x is positive here, so my answer would be quadrant 3. I've kind of hinted to these already, where I've said that, notice the connection between these. So the cosecant, we said, is 1 over y. Well, y is the sine, so that's a nice little connection to remember. Or a lot of times students will remember that the sine is the same as 1 over cosecant. In fact, if you remember when I was showing you how to switch your calculator from radians to degrees, and I said if you had something like cosecant, you would have to put 1 over sine in your calculator. So these are very helpful. The secant, 1 over x, or 1 over cosine, and then the cotangent is x over y. So if I do 1 over my cotangent, so let's write that out over here. So 1 over y over x. Remember that x comes to the top. Okay, so if I have something that looks like this, so if I have my 1 over y over x, then this piece down here, as I can see, is going to be 1 over the tangent. So these are very good identities to know. And for right now, one of the main reasons is if you're asked to find these values in your calculator, those don't show up as calculator buttons, so you need to know the identities to find them. The quotient identities, these are very, very nice. So let's go back and remember that the tangent is y over x. But remember, y is the sine, and the x is cosine. Very, very, very good one to remember that you will use a lot, is that the tangent is the same as sine over cosine. So same thing here, my cotangent, x over y. My x is my cosine, and my y is my sine. So these are called identities because They're identical, right? All right, what do we got going on next here? So some other trig identities. If I have the equation of the unit circle, which is x squared plus y squared equals 1. All right, that's the equation of the unit circle. Or I could turn these around and say y squared plus x squared equals 1, right? That's not changing anything. Well, if I say I have a point that's on the unit circle that corresponds to some angle theta, then I can say y is sine, so of course sine squared, and x is cosine equals 1. This is a very, 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 very important identity. Okay, so sine squared plus cosine squared equals 1 based off of being a point on the unit circle. If I take, and let's just start with this one, and let me see if I can get me another ink color here. So if I take this first one and I divide every term by cosine squared theta. So in other words, I'm going to have sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta. Remember, this is algebra. If you do the same thing to every single term, you didn't change the equation. Well, do you remember what sine over cosine is? An identity we just learned. That's tangent, but in this case, tangent squared. Cosine squared over cosine squared is 1. And do you remember 1 over cosine? Secant? Oops, I didn't mean to put the 1 there. Is secant squared theta. So based off of my reciprocal identities, I can come up with another trig identity. Well, I can do the same thing, but now over here, let's take this same function and divide everything by sine squared. So I have sine squared theta divided by sine squared theta. I have plus cosine squared theta over sine squared theta. And then I have 1 over sine squared theta. So again, I have my sine over sine, which is 1. My cosine over sine is cotangent, but again, this is squared. And then the reciprocal identity of 1 over sine is the same as cosecant. So these are some very nice, especially the sine squared plus cosine squared equals 1 are some very nice identities that you're going to see you're going to use a lot in this course. If I want to find exact values based off of the identities, well, I know that is the same sine over cosine, so that's the same as tangent. And so if I subtract those, I get 0. If I have something that looks like this and I want to be able to add these, well, once again, I remember that what this piece right here is going to be cosine squared. So let's rewrite it. So I have sine squared pi over 12 plus my reciprocal identity cosine squared pi over 12. Well, as long as these angles match and they're squared, sine squared cosine, that's my identity that equals 1. And let's stop right there and finish up the next one.